Hello, good evening, everyone. It's great to have you. I'm told we shouldn't use this microphone. I will stick to the orders here. It's great to have you here. We will have the fireside chat. So we're the only thing that stands between or in front of the all-exciting lab tour. So we will be exciting as well with the fireside chat. So I have Francesco with me, the founder, or one of the founders of Proxima Fusion. Let's kick it off. Let's take a step back, and why don't you tell us about how Proxima got started? What was the spark that got you together with your four co-founders to get started with Proxima? And I might remind people at that point that Proxima is only slightly more than 2 years old, which is amazing with all the visibility that Proxima has and all the achievements so far. So what got you started?
Cool. Do I need to use the mic? No. Is it important? Maybe not. Maybe it's slightly more approachable. So it's been said that we have to be exciting. So I'm supposed to say something compromising or offensive. I don't know. I'll try to be normal. We are a spin out from the Max Planck Institute for Plasma Physics, which has 2 centers, one in Garching near Munich and one in Greifswald. We work on so-called QI stellarators, so donuts with magnets, slightly twisty and complicated, as you might have noticed. When just looking at a drawing, you get a feeling for the geometric complexity. There is powerful magnets in this, vacuum vessels, cryostats. It's an ensemble of engineering that is humbling, let's say. We got started when in 2022 we saw a few things coming together. The first one was the Wendelstein Z7X or W7X, the most powerful stellarator in the world in Greifswald in the north of Germany, came into full operation, met all its design targets. It was amazing. It's an incredible engineering feat that device ever came together. And then in 2022, a publication came out, and that shifted me from the world of tokamaks, another branch of magnetic confinement fusion, to stellarators. So tokamaks have been the most conventional standard path. That's what I was educated in myself, with the mindset of stellarators sound nice. Nobody can really do them. Then it became understood that nobody could do them except the Germans. And we said, well, let's think European. Let's build something a bit more looking at the commercialization, bringing together the strengths of an entire European ecosystem. And final element of the story was that the magnet technology that would enable us to go to much more power than W7X was becoming. It was clear that it became much cheaper. Commonwealth Fusion Systems, or CFS for short, a startup out in Boston. They spun out from MIT at the time. My co-founder Lucio and myself were doing our PhDs there. CFS bought so much of this superconducting material, decreasing its cost by a factor of 5, showing that you can really make powerful magnets with this. And we started putting the things together. You know, stellarators, they are scientifically, there is a lot of a clear scientific basis, let's say. We knew that we could optimize numerically these devices for the things that W7X couldn't yet do when it was designed 20 years ago. And then these magnets. We knew then that we needed to become an R&D company with a heavy manufacturing component. And so we got started. We founded the company in early 2023. So 2 years and a bit.
You touched upon a lot of interesting things that we will go into a little bit more detail later. But there's one important thing for the founders in this room here. I think what's really, we invested with redalpine around 1.5 years ago, and since then we've been obviously witnesses to an amazing journey with amazing milestones. You published a Stellaris paper, which was hailed by leading figures in the fusion field as the most important milestone in fusion for the past decade. We had 200 million euros raised, the biggest funding round for a European fusion startup. You had milestones on the magnets. You had amazing talent that you hired from across the globe. How do you manage as a team to execute at this speed and at this level of complexity? Because we have to keep in mind that Proxima as an organization, as an operation, is super complex. It's not only the technology that's super complex, it's also the stakeholders that you have to manage. It's the politicians, it's the public perception that you have to manage, it's the communications that you have to manage. It's also the supply chain that you have to manage, and sourcing obviously the most coveted talent, which is in many roles very, very scarce. How do you succeed?
I think in all that complexity, the talent is sort of the start of the solution. You can't hope that 5 people or 8 people or 10 people really figure it out. You have to keep hiring people better than yourself. Arguably, that's the thing that you were probably glad to see, that we hired somebody better than what you invested in the first place. In some sense, it's never enough, right? So at every 6 months, Proxima looks like a different company in a number of ways. So we started out and we were not the experts of high temperature superconducting magnets. Then Nico Riva came in, and then Rob Slade came in, and every once in a while we brought in somebody who would just raise the bar in that domain, and we needed people with a certain entrepreneurial drive. And then we started looking at ecosystems and what sudden move could shake up things a little bit. We started working with the Paul Scherrer Institute, a national lab close to Zurich, close to where redalpine is based, and at PSI, as it's called in short, it's where we can access the fantastic pipeline of magnet talent. CERN is the place with the most superconducting magnet engineers on the planet, arguably, and so that's the single largest previous employer of Proxima. And then we figured that the UK magnetic confinement fusion community was also a great place to be, also very open to an entrepreneurial vibe. So we created a team there. Right now we are 100 people. We operate out of these 3 centers. We ship a lot of things across the border. Every once in a while, we got caught with strange pieces of metal that sound pretty dangerous, but it's all fine.
You're lucky there are no tariffs.
No tariffs, fortunately, yeah. And we try to keep the operational complexity as fast as possible. One of our earliest team members, Leonard Bock, he had as our head of operations, he had as a target, make Europe feel like the United States in operations. And that, I think, set operationally as standard. In the US, there are no borders basically, and you don't have to think about how do you cross the border with some complicated magnet technology. And so our ops team had to be at the same quality as our magnet engineers or our design engineers, right? Yeah. And that I think also helps. So having a group of people, each of whom looks at the others and says, we are all the average of the 5 closest people to us in terms of quality of execution, quality of creativity. And I think that's what we did best.
Yeah, that's amazing. Obviously, talent is a point, but you're brushing over the complexity that you then get with the internationalization and the operations. But what, from your perspective, because we touched upon this with the public perception and the policymakers that are involved or that play a crucial role, what do you think has changed in the perception of fusion over the past 2 years while you were active with Proxima? That could be from the point of view of policymakers, the public, investors even, and talent that you acquire. What has changed there?
We got lucky in a number of ways, that's fair to say. So we're doing a bunch of things right, but there is also an ecosystem that is pulling behind us. When we started, we did it naively from a technical perspective. We said the technical mindset here, the solution we're looking for, we believe it, but we didn't know that there would have been an energy crisis so heated up. We were not in control of how the fusion ecosystem, let's say, will heat up. Some of the things that have happened have been very helpful in ironic ways. For example, other fusion concepts have also achieved good milestones, and this has been a tide that has lifted all the boats. The credibility of investing in fusion has suddenly risen for reasons that sometimes are related to us, sometimes they're not. But that's how it works. The fusion industry now has raised more than $10 billion in total, which makes Proxima a little guy. So we are the little baby trying to fight Arnold Schwarzenegger. We have a long way to go. So it's nice to be, celebrated as a success story. But we are 2 years old. You'll see in the lab fast iteration on hardware, and this is small compared to what we're doing in Switzerland. So everything looks good. At the same time, we've just begun. That requires also the humbleness of realizing we're trying to build a fusion reactor. We're iterating on magnets. They're ever bigger. They're ever more complicated. And the journey is long.
So even in fusion, timing is everything. Right?
Yes. And I think the timing now with policy, for example, it's been amazing. When we started, we thought Germany had just stepped out of fission. Yes. And the single biggest risk for fusion is that people mess up the basics of what fusion and fission are. Sounds super stupid, but just as a reminder for everyone, fission, Kernspaltung, is the process of splitting a large atom. It's nuclear, we know it. We've been making power plants and also weapons with it, of course. Fusion, we've made weapons already in the 60s. That's an H-bomb. But the technology to make weapons and to make fusion power plants has literally nothing to do. Like, you cannot get an engineer across and just expect that they know how to transfer that know-how. The application of a fusion power plant would not have any long-lived radioactive waste. There is no chain reaction. I can go at length, but fundamentally the safety concept is entirely different. It's intrinsically safe. It's so good, fusion, that it's just, unfortunately, it's just bloody complicated. That's the problem. The German policy ecosystem seems to have clicked with that differentiation between fission and fusion. We had a part in this. We do a lot of policy work. Yeah. It definitely isn't just Proxima. There is also other fusion companies. There is an ecosystem of national labs, a lot happening also internationally. Today, we don't know of a single German major party that is against fusion. Yeah. And that is amazing. That's amazing. You know, we have a country moving together, and that we're very grateful for.
That's amazing. And you mentioned the overall, the global amount invested in fusion. And can you give us a view of the global heat map of fusion, so to speak? Where do we sit with Europe, with Germany, maybe with Stellarators, with Proxima, within that global heat map of US, China, and Europe?
Yeah, so much of the private venture capital has been raised in the United States, as you might expect. The US in magnetic confinement fusion is not larger, not better than Europe. The number of experiments, public research facilities in Europe is significantly larger, 7-8 times in the number of experiments, probably twice the number of researchers. So keep that in the back of your mind. In terms of private capital raise, Europe is still, at the beginning, let's say, less than 10% for sure. The single company that we as Proxima look up to the most and that we keep as those are the guys we're trying to catch up with, is called Commonwealth Fusion Systems, I already mentioned. CFS has now raised $3 billion, fully private capital. They also signed 2 power purchase agreements, one with Google, one with ENI, and they're very good. We know each other very well. We think very highly of them. They're working on what is called a tokamak, however, which is what I used to do research on. And we think we have a plainly better technical solution, which sounds nice, but we have to actually go and show it. Our solution is based on the same physics, fundamentally, but the engineering allows us to have continuous operation and full stability. And we think that's worth a lot when you're looking at commercial power plants. So we keep CFS in mind. China has been investing at Chinese levels in the past few years, and they really caught up with tokamaks at an impressive speed. We are expecting 2027, 2028 that both CFS and the Chinese, mostly public project called BEST, they are going to show net energy gain in a magnetic confinement fusion device, which we consider to be an incredible milestone that will turn rocks upside down, and it will be incredible. Then fusion hype will begin. Sometimes people ask me, are we in a fusion hype? And my answer is, you haven't seen it yet. Wait for that to happen, and then you'll see what fusion can really do. So right now, Europe is in the middle, has a fantastic public research ecosystem, has been the sleeping giant. Literally in a Financial Times article last year, it was said Germany is the sleeping giant in fusion, and maybe we woke it up.
And in particular in Stellarators. And I think it's worthwhile mentioning that the Stellarator technology that was also the reason for us to invest ultimately, besides the team obviously, that Stellarators is actually the technology that's the most likely that you can practically put on the grid. And that makes a huge difference. It's not only technologically more appealing, but it's really from a practical point of view to make it happen.
And even just quantitatively, you look at Germany hosts the most advanced Stellarator in the world, that's W7X. Proxima today has raised more private funding than all its Stellarator company competitors put together.
Yeah, that's amazing. Can you say a few words about where we sit as Germany? You mentioned that the Stellarator expertise that we have, but the other thing is the manufacturing expertise and the supply chain. How are we positioned there, in particular Proxima?
Those public projects, they've done a lot. Sometimes we think that research is moving at a different pace than startups. That's totally true, but it is definitely a foundation that we are building on. If you look at those 7 tokamaks and 1 major Stellarator that are located across Europe, those have created a supply chain that relies on the manufacturing base that is in continental Europe, which is so much bigger than in the United States that sometimes people don't quite realize. And if you are into a deep tech hardware startup, I recommend that you really embrace this incredible richness. The US has digitalized much faster. They've obviously built some amazing companies. And maybe as part of that comes the damnation of not having really a manufacturing base that is even closely as strong as the one that we have here. One number that I find always fun is there are about 550,000 CNC machinists, qualified CNC machinists in Germany, and about 300,000 in the whole of the United States. So we live in an area where most people are completely detached from manufacturing, but there is a population here, not just in Germany, but in northern Italy, in France, that loves the smell of metal. And that is such wealth. And so when you look at, you'll see in the lab components that have been hacked together, calling out the machine shops of Munich, which have responded in the number of 100 to tell you, yes, we can use this kind of steel. It's weird that you ask, but we can do it. And that is just, it's been a discovery. Yeah, I mean, Jonathan that you'll meet, he knows this inside out. He was like, yeah, I know this since I was 5. I didn't. And it's incredible wealth.
Yeah. It's a great position to be in, right? And that's a differentiator, and that's a head start that we have here in Europe, which is totally underappreciated, I think, and I think that's important. The other thing is, are you happy where we are with in terms of the policymakers? What is done on the politics level?
Am I supposed to say yes? We are going in the right direction. I am concerned about the speed of it. Generally, there is too much looking for compromises. So the fact that Germany and Europe broadly are embracing fusion, fantastic. And the fact that Germany today doesn't advocate for tokamaks at all. It's the only country on the planet that has realized that tokamaks should be put aside. There have been fantastic experiments, and they've built up our understanding towards accelerators. That's the way we see it. That's the official position of the Max Planck Institute for Plasma Physics. 1,200 people, one of the largest fusion national labs on the planet. That's incredible. So Germany has that momentum, but now we're looking at major national programs emerging, and there are a number of companies, and we should take the money and we should split it equally. Yeah. That's my greatest fear. The lack of competitiveness. Yeah. We want to win, but really we first want to compete. Yeah. So we'd like a fair process where we go at it and we show what we got. And that would be better for everyone, but somebody needs to have the guts to annoy somebody else and not fear to be sued. Because when people say, but if we go too fast, we might get sued. What are we going to do? How are we going to compete with the Chinese if we don't break some of this system, this cage that we are moving in the public system?
It's just too much at stake.
So we see lots of good attitude. Yeah. We don't know literally one politician that doesn't wish us well. Yep. And that is energizing. That really makes us feel like, we're not alone. Yep. But somebody needs to change the pace. And this is, again, it really feels like there is a system of a cage where somebody needs to open up.
Yeah. But that's a challenge that might be even more problematic or more difficult than fusion itself. Changing the pace.
We'll see. Hopefully we win that one. I think Europe needs lighthouse projects. So we do need to repair those bridges. We need those streets. We need those schools. At the same time, I personally believe that the continent, not just Germany, needs to be inspired by a project or more than one that show that we can do something to be proud of. The engineering culture of Germany is something that needs to be revitalized. We need to make sure that we don't become a lawyer culture, which is definitely the trend in both Europe and the United States. If people see that we can operate at a crazy speed and that we can get a talent density into one organization, regardless of what kind of organization, regardless of who are the shareholders, we just need big things. Yes. And this is politicians need to understand the trade-offs that come from culture, of innovation, culture of entrepreneurship, culture of speed. Yeah.
Talking about Lighthouse project, what are the milestones that we can expect from Proxima?
So now we're iterating on magnets. So we went from being basically a software company to being an R&D company. Now we're turning into a manufacturing company. Most of the magnet work is happening at the Porsche Institute in Switzerland. The other, between here, we have a lab that you'll see, and which is sort of developing fast iteration R&D. Every 2 weeks it looks completely different, basically. We're doing tests on our cables. So these are systems that can carry 50 kiloamperes. They are like very powerful cables. And then putting them into magnets, testing those magnets ever larger. We started from things that were yay big, Now they're getting a little out of hand. In mid-2027, we target a full-scale, full-power magnet. That's about 100 megajoules of stored energy. If that number doesn't tell you much, that's enough to melt the metal that the magnet is built with. So you have to control this power very carefully. So mid-2027, at about the same time, we need the full engineering design of what we call Alpha. That's the net energy gain stellarator that half of the team is designing. So only 50 people at Proxima are working on magnets. The other half are doing general stellarator design and integrated design.
You mentioned that in the journey of Proxima, we're kind of moving from that stage where we're kind of simulation first, getting a handle on the complexity of the magnetic field and the magnetic field configurations, to the manufacturing. With all the milestones that we've seen, what can we expect? Or what are the challenges on the manufacturing side, and what novelties, what innovation will you bring to manufacturing itself, actually?
So we think a lot about simulation driven, not just as a way to start, but it needs to be a mindset that is carried over. Part of how we got to be obsessed about simulation driven engineering is Martin, one of my co-founders, who is a mechanical engineer, was a McLaren Formula One, then went to Google, then Google X, then was head of simulation of a drone company, automated basically drones, and then general theme is simulation driven hardware design. And Martin brought this mindset of building frameworks to accelerate, take a hit at the beginning, but then think about integrated design in complicated systems that then carried over to stellarators. That is accelerating us all the time. In manufacturing, another key person that joined us is Bas Darcy. Bas was actually in Munich and Regensburg for 12 years, 13 years in BMW, then went over to the US, was in SpaceX, became senior director for production. So he built up basically the factories of SpaceX. Now he's our chief technical operations officer, leads all manufacturing. And then he was also CEO of Cambridge Medical Robotics for some time. And the combination of these two people kind of gives you a hint of where we're going. Simulation-driven manufacturing. If you look at Germany, the basis of manufacturing is incredible, as said, but it's still a bit old-fashioned. It's still excellence in the way we manufactured some time ago. With exceptions, of course, there are some amazing realities already there. We don't need to reinvent the wheel, but we do need to enable it to iterate faster. And I think some of this will involve vertical integration. So I think Fusion calls for basically, if you deal with mediocrity or you deal with slow motion, delays accumulate, and it's just not a challenge that lends itself to mediocrity, let's say. So we're going to have to build an ecosystem to accelerate manufacturing.
There's going to be further excellence in manufacturing in Germany.
That's the plan.
Getting it to the next level. I'm just looking at the clock. Can you, before we get a couple of Q&A, can you give us a glimpse of the future with Fusion? And Proxima obviously at the heart of it.
Yeah, so the picture of why Fusion, I think many of you probably appreciate it already. We're looking at stellar power in a lab. The systems will not be small, they will not be simple, and they will not be cheap. When you look at the power that they can make per amount of steel, however, this is impossible to compare to other things. You should be thinking basically about a power plant that does not consume fuel effectively. You power it with some heavy hydrogen that you can get from seawater and from lithium, some amount of lithium, which looks like a lot, but actually on the scale of energy that you're making is not that much. It's a technology that could basically decouple wealth from natural resources. And that's maybe a way to look at it. Today, power around the planet is held by those that have the ability to pump out something from the ground. And that is basically how world politics works. If you got fusion power plants and you were able to deploy them fast enough, you could reach energy independence. You could basically power up your industry that is suffering with energy prices. You could turn it into a geopolitical power element. And Europe kind of needs some of that. We are not doing it just for Europe. We are strongly committed as a European company. The identity is very much about Europe for us, but we want this European company to export this for desalinization in India, for powering the Nigerian communities. Every city of 1 million people needs at least 1 gigawatt of hopefully clean energy. That would mean a 1 gigawatt stellarator or 2 500 megawatt electric stellarators. So the picture is to deploy as fast as we can. In practice, there is a limitation to how fast concrete you can pour, how much steel you can get, and that's the mindset. We need to go as close as possible to that limit of physical goods. Yeah. And that will carry us into the 2050. And if we get to 2050 and we've deployed 50 fusion power plants, this is a company that is worth $1 trillion.
Absolutely. The impact is just amazing, right? And that's the big difference to other companies. I mean, no matter how close you are in this room to Proxima or will be in the future, everyone's going to be affected. And I think that's just amazing.